All right, let's look at a process called factoring for quadratics. So remember, quadratic is just the name we give to anything that has a squared term. And so if I've got my squared term, then I can also have one that is to the first degree and then one with no variables. And when we put a, b, and c in here, we just refer to this as standard form. It's just a way to generalize the conversation about our quadratics, where a is just the coefficient on the x term, b is the coefficient on the x, and c is what we're going to use as a placeholder for the constant term that's in the expression. And all factoring does is it converts it from this standard form where everything's been multiplied out back into the two linear binomials that were multiplied together to get that. That's going to give us some really important information the more we work with quadratics. So for right now, we're just going to practice the mechanics, the skill of breaking it into those two pieces. And we're going to do that with the example negative 4x squared plus 10x plus 6. So this is our reference problem so that we can get a set of steps that actually make sense and have some context. The first thing we need to do is look for a GCF and ensure that A is positive. Okay, we're going to group those together because we need to check every slot and see, is there a number we can divide out of all of these? And for most of them, it's pretty obvious that I can take a 2. But because our a value is negative and I need it to be positive, I'm going to divide out a negative 2. I can always multiply or divide by a negative, and doing that here will make that be positive. So when we do that, we're going to write down the negative 2 that we divided out. And what's left, 4 divided by 2 is 2x squared. 10 divided by negative 2 minus 5x. 6 divided by negative 2 minus 3. Once we've got that taken care of, we're going to remember we pulled this negative 2 out, but then just kind of set it to the side because this is the expression we're going to factor. Just the 2x squared minus 5x minus 3. At this point, then, we need to identify what A is, what B is, and what C is. So the number sitting in front of x squared is 2. The number in front of the x term is negative 5. And the constant value is negative 3. We do that so that we can multiply A times C. In this case, 2 times negative 3 equals negative 6. And I need to remember that my B value is negative 5. Once I have those numbers, we're going to set up one of those little diamond problems like we did in class the other day. And my AC value, so negative 6, goes on top, and my B value, negative 5, goes on the bottom. So just like we did in class, I need to figure out what two numbers multiply together to give me negative 6, and when I combine them, I'm going to get negative 5. So if I think about all the numbers that multiply to give me 6, I can do 1 and 6 or 2 and 3. But I also need to, when we multiply, they're negative, which means one of these is going to be negative, and I need to somehow end up with a negative 5. Well, if I do 1 minus 6, positive times negative gives me negative, 1 times 6 is 6, and then 1 minus 6 is negative 5. So I know I can do 1 and negative 6 to make my little puzzle work. Before I can use those numbers, though, because this negative 6 was the result of multiplying A times C, I have to undo that before I can use it. So I've got to divide the 2 back out. When we do that, we're going to use those values after we simplify them. So 3, we're going to simplify. Our values. 1/2 is just going to stay a half, but -6/2 simplifies to -3. And these are what we're going to use to build our binomials. Okay. So my binomials, when we write them, okay, they're both going to start with x, and then these values are what we're going to plug in. -3, +1/2. Now, it's not really great form to leave this as a fraction. Factoring implies we want to work with just the integer values. The way I fix that is by technically multiplying through by a 2, but what ends up happening is this 2 comes up here. So if you're searching around, you'll see things called the bottoms up method, where I take the bottom and move it up, and that's what happens here. 2x + 1 times x - 3. Now, if you multiplied this back out or put it in y equals with your calculator to check the tables, you'll see that it's not the same thing. But that's because we pulled out this GCF up here. We're not finished until we bring that back down in front and have the completely factored form . Completely factored form of our original expression.